Myself Adarsh Sharma, roll number 6. I am going to tell you about rest of pharmacodynamics. Dose response relationship. The pharmacological effect of a drug depends on its concentration at the site of action, which in turn is determined by the dose of a drug administered. Such a relationship is called dose response relationship. Now, types of dose response curve. There are two types of dose response curve: graded dose response, quantile dose response. Graded dose response curve, when plotted on a graph, takes the form of a rectangular hyperbola, whereas log dose response curve is sigmoid shape. Quantile dose response curve, certain pharmacological effect which cannot be quantified but can only be said to be present or absent, like all or none, are called as quantile responses. Example, a drug causing ovulation. Now, what is therapeutic index? Therapeutic index is an index of a drug safety. Formula of therapeutic index is median lethal dose of a drug upon median effective dose, means LD50 upon ED50. LD50, it is the dose of a drug which is lethal for 50% of the population. ED50, it is the dose of drug which is produce the desired effect in 50% of population. Higher the value of therapeutic index, safer is the drug. Example, penicillin has a higher therapeutic index. Digitalis, lithium and phenytoin has a narrow therapeutic index. Now, what is drug potency? Drug potency, the amount of drug required to produce a desired response is called the potency of a drug. The lower the dose required for a given response, the more potent is the drug. Example, like analgesic dose of morphine is 10 mg and that of pethidine is 100 mg. Therefore, morphine is 10 times more potent than pethidine as analgesic. DRC means dose response curve of two drugs. Drug A, morphine, and drug B as analgesic can be compared in form of graph. Drug efficacy, it is the maximum effect of a drug. Example, morphine is more efficacious than aspirin as analgesic. Now, what is therapeutic window? It is the range of concentration of the drug which produces desired response with minimal toxicity. Combined effect of the drugs, a combination of two or more drugs can result in an increase or decrease in response of drug. Increased response. First, additive effect. The combined effect of two or more drugs is equal to the sum of their individual effect. Effect of drug A plus B is equal to effect of drug A plus effect of drug B. For example, combination of ibuprofen and paracetamol as analgesic. Potentiation or supra-additive, the enhancement of action of one drug by another drug which is inactive is called potentiation. Means effect of drug A plus B is equal to is greater than effect of drug A plus effect of drug B. For example, levodopa plus carbidopa, acetylcholine plus physostigmine. Carbidopa and physostigmine inhibit the breakdown of levodopa and acetylcholine, respectively, thus enhancing their effects. Now, synergies. When two or more drugs are administered simultaneously, their combined effect is greater than elicited by their either drug alone. For example, sulfamethoxazole plus trimethoprim is greater than pyrathiamine plus sulfadoxime. Decreased response, it is also called drug antagonism. It is antagonism, the effect of one drug is decreased or abolished in the presence of another drug. First, physical antagonism. The opposing action of a two drug is due to their physical property. Example, adsorption of alkaloid by activated charcoal, useful in alkaloid poisoning. Second, chemical antagonism. The opposing action of two drug is due to their chemical property. Example, antacids are weak bases. They neutralize the gastric acid and are useful in peptic ulcer. Chelating agent complex metals and are useful in heavy metal poisoning. Example, dimecroprol is arsenic poisoning. Physiological or functional antagonism. Here two drugs act by different receptor or by different mechanism on the same physiological system and produce opposite effects. Example, insulin and glucagon on blood sugar adrenaline and histamine on bronchial smooth muscles. Histamine produces bronchoconstriction via histamine receptor, whereas adrenaline produces bronchodilation by acting through adrenergic beta 2 receptors. Hence, adrenaline helps to reverse bronchospasm in anaphylactic shock. 4. Receptor antagonism. The antagonist binds to the same receptor as the agonist and inhibit its effect. It can be competitive or non-competitive. First, competitive. This is called equilibrium type. In competitive antagonism, both agonist and antagonist bind reversibly to the same site on the receptor. For example, acetylcholine and atropine both bind to muscarinic receptors, and morphine and naloxone both bind to opioid receptor. In this, morphine and acetylcholine are agonist and atropine and naloxone are antagonist. Equilibrium type of competitive antagonism can be overcome reversible by increasing the concentration of the agonist. The log dose response curve of agonist show a right toward parallel shift in the presence of competitive antagonist. Non-equilibrium antagonism. The antagonist binds to the same site on the receptor as agonist, but binding is irreversible. The antagonism forms strong covalent bond with the receptor. Example, phenoxybenzamine is an irreversible antagonism of adrenaline at alpha receptor. Second type, non-competitive antagonism. The antagonist binds to a different site on the receptor and prevents the agonist from interacting with the receptor. In this type, the antagonistic effect can be overcome by increasing the concentration of agonist. There is a flattening of dose response curve is non-competitive antagonism. Example, diazepam and bicuculline. Thank you.